In a previous presentation, we discussed the conservation of matter, which in plain English means that in a chemical reaction, you're not creating or destroying matter, but just changing it into different types of particles. And we can discuss the conservation of matter in terms of atoms, molecules, elements, and compounds. So for example, we want to be able to make sure that in a reaction that we have the same number of atoms on the left as we do on the right. So as an example, here CH4 plus O2 forms CO2 plus H2O. We have to be able to balance this. On the left side, what we have is called a particle molecule of carbon, hydrogen, and oxygen. And on the left side, we have one carbon atom. On the right side, we have one carbon atom. On the left side, we have 4 hydrogens and 2 hydrogens. And the left side, we have 2 oxygens and 2 oxygens. And we have to find a way to balance this equation. So we're missing here we have 3 hydrogens and, 3 oxygens and 2 oxygens on the left. So to balance this, we have to find a way to change this around. So if, for example, we add a 2 on this side here, that would make 4 hydrogens. We add a 2 there, now I have 2 oxygens, and 2 oxygens would make 4. So on the left, I would put a 2 in front of that oxygen, and that would balance the equation. Another reaction, H2 plus O2 forms H2O. In my particle molecule, I have H2O2, and this is a molecule of water. So I have 2 H's on the left, 2 H's on the right. In this situation, now I have 2 oxygens and 1. I would put a 2 in front of this, which would balance out the oxygens, but now I have 4 hydrogens and 2. So to balance it again, I would have to put a 2 in front of this hydrogen. And the balanced reaction would be 2H2 plus O2 forms 2H2O. I have 4 hydrogens, 2 oxygens, 2 oxygens, and the particle model is balanced. I have 4 hydrogen atoms here, 1, 2, 3, 4 here, 2 oxygens, and 2 oxygens.